I'm Dave. I'm a programmer from Ann Arbor, Michigan. Since last spring, I've been working on a user interface toolkit for Clojure called Seesaw. The idea behind the Seesaw is to build a set of code that lets you, that makes the construction of user interfaces, desktop applications, applets, more pleasant or at least bearable in Clojure. Seesaw is built on top of Swing. There, I said it, and I don't feel that great about it, but that's the way it is. Swing doesn't have a particularly great reputation, and I thought it'd be worth spending a few minutes talking about why it is the way it is, how that affects you as a developer, and how that affects the design of Seesaw. So, if you take Swing, you've got a lot of missing abstractions, concepts that are missing, inconsistent APIs, kind of slavish slavish devotion to backwards compatibility, neglect by certain corporations over the years, and the arms and legs that grow on software as it's maintained over a long period of time. These things all kind of come together in the development process as frequent trips to Stack Overflow, various abandoned forums from the early 2000s, and generally feeling that this is not something I feel like doing. I'm not enjoying this. You could say that Swing is neither simple or easy. It is complexity and difficult. On the other hand, a developer with enough fortitude and hubris can build the kind of user interfaces they might want with Swing. And it's stable, available, has no native dependencies, and there's a ton of people out there that actually know it. If you ask a question on Stack Overflow, you'll probably get an answer, which is nice. So I think that makes it at least a viable candidate for building an interface toolkit for Clojure. So how does this affect Seesaw's goals? Well, we want to address all those missing abstractions, add unified APIs to address them so that you don't have to go to Stack Overflow as often. Address all the gotchas and hacks and workarounds that you have to find out about when you're building Swing applications, usually the hard way. So hopefully you can just use something in Seesaw without having to learn about it ahead of time. And make the common case easy, but every case possible. So there shouldn't be anything in the Seesaw API that precludes you from doing something that you could otherwise do in raw Swing. And if there's something that you take away from this talk, even if you don't build UIs, it's the idea that Clojure is pretty awesome, and even for a moldy, yucky old API like Swing, it still has a lot of value because it's not something you'd actually want to build yourself. And Clojure gives us the tools to actually make that, breathe new life into those APIs and make them usable again. So let's talk about Seesaw. First thing you probably want to do is to make a widget. We'll start with a little hello world. Here's some Swing code. It looks pretty blocky. A lot of setters there where this little hello world takes a label, jams it in a frame, and displays it. The structure of the UI that comes out of this code is totally unapparent from the structure of the code, and it's generally a mess. If we introduce Clojure to the mix, especially with a do-to macro, we can the structure of the code reflects the structure of the UI a little more now that the frame is actually, or the label is initialized within the construction of the frame. But there's still all those setters. You have to know how to build colors, and you have to know about these enumerations. And it still doesn't look like Clojure code to me. It looks like interop, which is yucky. So here's the same code again in Seesaw. So widgets in Seesaw are constructed with these widget constructor functions, which take a keyword value pair list of the initial values for the widgets you want to create. And pretty much all of that cruft and stuff has fallen away, and you're left with a pretty nice looking piece of code, I think. Part of the reason for that is that Seesaw supports a lot of shortcuts for constructing things like colors. So if you need a color, you can give it a color name, a CSS-style color string. If you want a font, you can use a font descriptor or a map that describes the properties of the font you're looking for. Say you want an icon. Seesaw will take something that looks like a URL, a class path resource, and it will take care of the details in constructing the icon for you. You also note that some of these examples have a namespace qualified keyword on them, which maps to Seesaw's internationalization support, which allows you to unload all these kinds of things, including strings, to resource bundles so that they don't have to litter up your code. And there's a number of other shortcuts like keystrokes, dimensions, borders, which for some reason in Swing are particularly verbose to build. And all these things come together to make the code much more readable. Once you've constructed your widgets, you'll probably want to change them over time a bit. And then the config function takes a widget, and just like the constructor functions, a list of keyword value pairs of the properties you'd like to update. And once you've updated a property, you can actually also ask for its current value, and you'll get the current value back. You'll note that the return value here is a raw Swing object. So one thing that Seesaw doesn't do is it doesn't wrap anything in the Swing API. Everything is still a raw Swing object. So if there's something not covered by the Seesaw API, you can drop to interop immediately without any ceremony. And hopefully that doesn't happen too often, but that is available to you. You also note down in the right-hand corner of some of these slides, there's a little def protocol or multi-method indicator, which indicates that whatever's on the slide is backed by a protocol, so you can extend it to your own widgets or third-party widgets so they can play seamlessly with Seesaw. So you've got your widgets, your users entered some data into them, and you want to work on that data, and you'd like to get the value of your widget out. I'll note that all of this stuff is inspired by, some may say stolen, from Stathis Sedaris's Clarity UI framework. I thought it was a cool idea, so I took it. And the idea is that every widget's going to have a kind of natural value that you'd like to get out of it. So if you have a text box, you'll get the current text of the text box out. A slider, you'll get the current slider value out. Combo box, you'll get its current selection. And that, this kind of abstraction is the idea of reducing the amount of stuff the developer needs to know about something in order to get what they want done. So you don't have to go to the Java docs to find out how to get these things out. You just call the value function, and 95% of the time it does what you want. And you can also extend this idea to composite widgets. For example, a form, say if you have first name, last name, sex, and age in a form, you can display that form with a dialog, and after the user's done some stuff with it, you can call the value function on that form. You'll get back a map of the values in that form indexed by widget ID, and that's ripe for destructuring and things like that. There's also a setter version of value that will let you push a value or a map into a widget to initialize its value. So how do you actually react to the user doing something interesting in your user interface? Events. Plain old Swing has very classic 90s observer pattern approach to events, which is related events bundled together into listener interfaces as methods. You implement that interface, register it with your listener or with your widget, and your methods will be called when things happen. And in practice, that means, say you wanted to handle your mouse click, mouse move, or resize events. Well, now you get to reify or proxy 3 separate interfaces, call the right thing to register them, and generally hate your life. Now, that's a ton of cruft and overhead for something that's conceptually as simple as, I know the event I want, here's the function I want you to call when it happens. And that's the approach that Seesaw takes for handling events with the listen function. So with listen, you give it a widget and a list of event name handler function pairs, and Seesaw takes care of all the details of reifying interfaces, registering them quickly with the widget, and making sure that your functions get called when the events happen. Seesaw also has support for a few pseudo events, which are events that don't have a one-to-one mapping to underlying Swing events. In particular, probably the most interesting one is selection. Finding out when the selection changes on a widget in Swing is always a bit of a research project in itself. For a list, you would implement a list selection listener and add it. In Seesaw, you would just say listen, selection, function. Next. So say you have a tree. Well, in that case, you'll do a tree selection listener and register it. And in Seesaw, you'll just say listen, selection, done. Now with the table, you need to know that you add a list selection listener on the list selection model of the table. And in Seesaw, you say listen, selection, and you're done. And this abomination here is a mutually exclusive group of radio buttons. Yeah, it's a horror. And this is how you handle that in Seesaw. So you can get a lot done with listeners. You'll end up with some callback spaghetti, and that's fine, but sometimes you'd like to express how the data is actually flowing through your user interface more declaratively, and so Seesaw has some support for binding widgets together. So imagine you have a checkbox which you'd like to control whether a particular button is enabled or not. So with Seesaw, you can just call the bind function and pass it your checkbox and the enabled property of a button. And now whenever that checkbox changes, the enablement of that button will be updated for you. That's fine. Doesn't save you a lot of work over a plain old listener, but it is more declarative. If you have more things involved, say you have a status label that you'd like to update its color and text based on the value of that checkbox, you can use this T function, which splits a value across a number of targets. So you can continue to pass it along to the enable property or button. And you can also transform it into color, pass it to the background property of your status label, as well as transforming it into a string and showing that on the label as well. This is nice and declarative, shows exactly how you want the data to move through the UI without having to puzzle through a bunch of callbacks trying to understand exactly what they're doing. Finally, say you have some kind of sound synthesis engine. I can't think of one offhand, but you were building widgets for it. Say you had a synthesizer that had its volume stored in an atom. This is all backed by a bindable protocol, which is extended to atoms. So you can hook your slider to the atom, and you can hook the atom back to the slider. And now any change to the slider will be reflected in the atom. Any change in the atom's value will be reflected in the slider's position, even if that change happens externally from the user interface. And we've been able to use that to pretty great effect in some of the overtone widgets, which is kind of fun. Now, we've got a nice way of building up a user interface in a kind of declarative style, maybe somewhat like HTML. And we've got a nice way of adding behavior to widgets with listeners and binders and things like that. Once these two ideas meet, things start to break down a little bit, because in order to bind something or to listen on a widget, you need a handle to that widget. But if the construction of that widget's buried down in a bunch of indented way over here, you don't have a handle to that. And once you put it out into a let, then now you're back to that first bit of Java code I showed where you have to instantiate things in two different places and put them together. So Seesaw has a way of fixing this, which is similar to modern, I guess, web UI development, which is to use selectors. What I did was I took Christoph Grand's in live HTML transformation library, and I took the selector query stuff out of it, and I tortured and abused it until it was willing to operate on swing widget hierarchies instead of DOMs. So now you can do things like select for a widget by its identifier, select for groups of widgets by class, or do more complicated CSS-style queries for things. Select will return a sequence of all the widgets that match whatever the query is, which is convenient because both the config function and the listen function are vectorized, so their first argument can either be a single widget or a sequence of widgets to apply changes to. So you can do stuff like disable every widget in a hierarchy with one call, or add a common handler function to a group of widgets all in one shot. So at least avoiding a do-seek there. And of course, now you can separate the layout from the behavior of your code. You can build up your user interface in one place, free of any actual behaviors, and then in another place, add behaviors back into the UI by digging into it using selectors and adding behavior after the fact. This also works, say, if you built a user interface in a WYSIWYG interface builder like Eclipse has, or IntelliJ maybe. I've never used that, but Eclipse has one. So you can hook in closure code after the fact to Java code that you've generated from a UI builder. So, cool. You might be thinking something like what Rain's here expressed to me, which is, that's neat, but I don't even really know Swing. I might not even know Java. And the idea of learning either of those makes me angry. And although I don't have either of those problems, I can empathize. So I've tried to do a few things in Seesaw to kind of temper those problems. First off, the documentation strings for an open source project, I think you'll find are quite extensive, including descriptions of the parameters they take, notes on internationalization, example usages, references to relevant Java doc in case you have to look, and other related functions in the API. Thank you. There's also a nice namespace called seesaw.dev, which has a couple useful functions in it. First off, there's a function called showOptions, which, given a widget, will print out a list of all of the properties that you could pass to that widget's either constructor function or config, along with example values and notes, so that you can see the kinds of shortcuts that are available and references to where you might look to find out more about those things. Similarly, for events, you can call show events, and you'll get a list of all of the events that you can possibly handle on that widget. These things taken together should hopefully make for a more interactive, closure-y, REPL-driven, fun development process without having to go to Stack Overflow or be an expert on Swing, hopefully, and address some of those issues. That covers kind of the high-level junk in Seesaw. But Swing is a gigantic API. Seesaw covers a lot. And so there's a bunch more so I've kind of scratched the surface here. So there's a huge test suite, internationalization, graphics, timers, drag and drop, key binding, full screen support, lots of stuff there. Basically all the stuff that I personally find horrible about using Swing, I've tried to put a happier face on the front of it so that it's a little friendlier to use. Also, Swing is an ancient technology, and there are some things that you just don't want to try to do in it, particularly animation. JavaFX JavaX2 has recently come out and has support for scene graphs and animation and some nice modern UI stuff. And I've been working slowly on a Seesaw-based version of that with the same protocols, same abstractions as what are used in Seesaw. I can't promise anything by summer 2012. That would be nice, though. So, recap. You can construct widgets. You can change them over time. That's pretty cool. You can get the value of a widget. And you can add behaviors to widgets and bind their properties together so you can avoid listener soup, hopefully. You can use selectors to separate the layout and behavior in your user interfaces. And we've got a bunch of stuff that should make development in Seesaw much more closure-y and pleasant. And that's all about Seesaw. Thank you.